Hi, welcome to your first pre-recorded lecture for BISC 160. Today we're going to get started by looking at Chapter 1 within your textbook. I'm going to walk you through exactly how these pre-recorded lectures are going to look today, and then I'm also going to teach you a little bit about how we do biology. So in most cases, what will happen as we go through these lectures is you'll start to see a slide and us in a small window next to that slide. At the beginning of each of our pre-recorded videos, we're going to have some objectives that we set out, and hopefully we'll remember to also put in an approximate date where you should have things completed to stay on track. Listed below that will be the 4 objectives or 3 objectives or 2 objectives of a given video that tell you exactly what you should be able to do. And then below that, it gives you information about the textbook, where you can find the information from this current lecture, and what you should be preparing for in the future. So in this case, today in this pre-recorded lecture, we're going to have section 1.3 about the scientific method, and then you should be pre-reading chapter 1, sections 1.1 to 1.2. So we're going to go ahead and get started by telling you guys a little bit about biology. So biology is the study of living things. This is a definition that most of us have memorized early on. This course is a course that many of you are in because it's required. And it's required because you'll need a solid background in biology for whatever you're choosing to do. For those of you in the biology major, you need this as a prerequisite for other courses. For those of you in something like pharmacy or who are in another major but plan to go pre-med, again, the goal is the same. You need to have a solid background in biology to go on throughout your major. But biology is a huge discipline, and it's a science. And so when we think about what a science is, it's really a structure of understanding the natural and physical world using experiments and observations. So when we think about the fact that we're using observations and experimentation, there are a couple things we want you guys to understand. First, there's a lot of organizational stuff about how we look at biology. There are things like naming and explaining what a particular living thing is. But all of it, whatever we do, it's all going to be carefully documented based on observations and experiments done by scientists in the past. So in biology, you're going to learn many just what seem like simple facts. Many of them, you guys have already thought, I've been memorizing facts about biology for ages. But each of these facts that you learn is based on observations, experiments, done by many, many scientists before you. All right, so every time you're memorizing a fact, recognize that we can't possibly teach you every single experiment that's been done to understand something, but there is a lot of observation and experiments behind it. Your book tries to get you familiar a little bit with how this scientific method works and how biology is studied by showing you a chapter opener that's a specific example of something that's related to the material in the chapter. They also have little sections called Investigating Life or Working with Data to help you understand how we come to the conclusions that we do in biology. And then we also, as your faculty, have designed homework assignments that bring in some recent research to talk about, hey, this all applies to even a bigger picture than you realize. So now let's talk about how we do science and how we do biology so we understand how we're studying living things. So, like other sciences, we use observations to build hypotheses. We all notice things. In science, we quantify these things we notice as observations, and that is our data. We can make different types of observations. We can make qualitative observations. For example, the frog in the middle of this picture has red spots. That's qualitative. But if we were to go in and measure how much red is coming out of that frog, that would be quantifying the observation by measuring how much of a certain thing you have. In this example that I have up here, this is Dr. Rebecca Tarvin. She is a faculty member at the University of California at Berkeley, and she is interested in studying these frogs known as poison frogs. Based on observations from many other scientists, both qualitative and quantitative observations before her, she's made 2 summary statements. Both of these are qualitative statements. First, poison frogs produce compounds that cause paralysis in vertebrates. And we also know that because these frogs have a backbone, they're also vertebrates. Both of these concepts right here are qualitative observations, as I said. If you wanted to make them quantifiable, you could say something like, it takes 50 poison frogs to paralyze an elephant. Okay, that would be a quantification of the observation of the first bullet. Dr. Tarvin took these observations and began to ask questions such as, why don't poison frogs poison themselves? They're vertebrates, so shouldn't they also be paralyzed by their own toxins? And she said, are poison frogs then resistant to their own toxins? From these questions, she then can make a statement that are consistent with the observations you see here, but she also proposes how that might work. So when you take the observations and you propose a way that they're going to work or how it's happening, you are building a hypothesis. For example, if she follows the question, are poison frogs resistant to their own toxins? She could say, poison frogs are resistant to their own toxin because they do not have the same structures that allows toxins to harm other vertebrates. And that would be her hypothesis. Okay, so she's created her own hypothesis. Now, from that hypothesis, she can go further and she can make a prediction. And she could specifically say that perhaps they don't have the same structures, or their structures are a different shape than other vertebrates. So she could maybe look at the shape of whatever's responding to the toxin and see, is it different? Does it have a different shape that does not bind to the toxin? Now she has a hypothesis and a prediction. So a prediction is when you actually go in and you make a statement that was consistent with your hypothesis, and how is it consistent with your hypothesis? What we've been doing here, these observations, the questions, the hypotheses, and predictions, is known as the scientific method. Now, the scientific method can be done in a lot of different ways, but it generally has these same 5 steps that are shown here in yellow in the picture on the right. What you'll notice is there are 5 steps in the flow chart, and you've already done the first 3. So when you make observations, you ask a question, you form a hypothesis, you would then move on to make a prediction. What else would be true if your hypothesis is correct? Right? So one thing that would be true if Dr. Tarvin's hypothesis is correct is that poison frogs would not respond to their own toxin. Okay? She could then design and conduct an experiment that uses quantifiable data to test whether or not they are resistant to their own toxins. So when we talk about experiments, we can talk about how do we do them. So the goal of an experiment is usually to falsify what we call a null hypothesis. And the null hypothesis is a statement of no effect. So in Dr. Tarvin's example, it would be there are no differences in the way that these poison frogs respond to the toxin compared to other vertebrates. All right? So that's something that she would be setting as a null hypothesis. And then she'd design an experiment to see whether or not she can reject or falsify that null hypothesis. So I want to talk a little bit about types of experiments, because there are different ways you can go about things when you do an experiment in science. So we can call these experiments either compared or controlled experiments. Both are valuable. So one way to look at this is to take a set of conditions and replicate them in the lab, and then expose our 2 different replicates to different things. So in this example, I'm using another professor from the University of Berkeley, Dr. Tyrone Hayes. Dr. Hayes is interested in the effect of this pesticide called atrazine on living things. He uses frogs kind of like Dr. Tarvin does, but he looks at all frogs. And what he's interested in knowing is whether or not atrazine has an effect on male frogs. We do know that exposure to atrazine, or he hypothesizes that exposure to atrazine can affect the sex of a frog, specifically based on observation that he's seen. He suspects that exposure to atrazine changes male frogs into female frogs. So he makes the prediction that higher exposure to atrazine results in more feminized males, so males who produce eggs instead of sperm. So if he wanted to test this hypothesis, he could actually do 2 types of experiments. One, where there's atrazine in the lab, and he takes replicated tanks of frogs like you see here in the purple box, and he exposes some of those tanks to atrazine and some to not atrazine, and he compares what happens to the frogs in those tanks. When you have a situation where you manipulate one variable the exposure to atrazine, and then you don't manipulate that variable in the other tanks, that's a controlled experiment. This is great because then you can take the results of exposing the frogs to atrazine and the results of not exposing them to atrazine and compare the results. Do you have more feminized males when exposed to atrazine? There's another way to get at this though, and that is with something called a comparative experiment. Comparative experiments don't have that control like you have in the controlled experiments. Instead, what you do is you go out into the natural world and you compare among different things with different variables already existing in nature. So in the orange box below, you see a map of the United States with numbers posted along it. So 1, 2, 3, 4, 5, 6, 7, 8. Dr. Hayes went out into the field, collected frogs from each of the places where those numbers are, and he looked at whether or not male frogs, whether or not their testes were producing eggs. And he compared that to how much exposure to atrazine they had. Okay? But the goal is the same. So what he's doing is saying in nature, if you have all of these different tanks or all of these different ponds in nature and they have different amounts of atrazine, do we see a similar pattern where males exposed to higher levels of atrazine have testes that make eggs? And they can be used together to answer the same question. They're just two different types of experiments. So once you have these types of experiments, what you want to do is look at whether or not there are differences between them. Are there differences between the controlled and the control population and the exposed to atrazine population? Or if you have, or similarly, if you go out into a comparative experiment and you say, how, given ponds 1 through 8, are there more feminized males in the ponds that have higher atrazine? You use statistical tests to evaluate whether or not they are really different from one another. Now, when we do homework assignments, we will walk through the types of statistical tests we can use. And our goal is to hopefully get you familiar with what specific tests are doing rather than exactly how to do the math. So we'll help you through how we do that in science. And we use those statistical tests to make sure that the results we have are strongly or not strongly supported. So what we're going to do now is you're going to close out this video and you're going to go to a section in the course that has a document titled COVID Questions. What we're hoping to do is get you guys to apply some of the stuff you're learning to this current pandemic. We have biologists out there making observations about COVID-19 and the virus SARS-CoV-2, and this is a great opportunity for us to practice science. How would we make a hypothesis? How would we make a prediction? So you're going to go into a document entitled COVID Questions that I created from different questions that show up on my social media. And from that document, you're going to select one of the questions and write a hypothesis and prediction for that question. That's the big picture. Within Blackboard, within the section that has this document, there are also going to be specific ways you guys need to submit this so that you get credit for the activity. We know that some of this stuff is going to be overwhelming trying to learn all of these new different tools that we have, but we're going to work through this and hopefully you guys will give us feedback about things that are working and not working as we go through.